but um and its applications. All right. So what is like Vietta's formulae? Does like anyone know? I mean, yeah. Okay, Isabel, do you want to like either unmute or say it in the chat? Useful stuff you can find about the roots. Yeah, it is like useful to like find stuff about the roots. So it's basically like when you have like a quadratic or cubic and then you can't and then the roots are really hard to like solve for, you can just use Vieta's formulae to like not find the roots but still get like useful information about the roots and stuff. Yeah. Okay, so um basically Vieta's formula is I mean Vieta's formula for quadratics is like if you have like a quadratic a oh my god. Can we not move um the PDF, please? Thank you. So if you have like ax squared, actually I'm just gonna copy and paste because this is so hard to write. So basically, if you have this quadratic, this quadratic up here, and then you know that like the roots are x1 and x2, but like you don't necessarily need to know what like x1 and x2 are. You can conclude that you can conclude like two things, which is shown here. Like the sum of the roots is like negative b over a, which means like it's like the second like negative this over this, and then the product of the rule of the roots is just this over this. Does that make sense? Can I get it like a thumbs up if it makes sense? Yes, okay. Yay. Kind of like what doesn't make sense? Can you like so I can go over it again? Melody. Okay. It's good. Okay. So now you like know the formula. Can we like prove it? I'll give you guys 1 minute and then you guys can try and prove it. And actually, I'll give you guys 2 minutes and then someone can just put their hands up or type in the chat. Okay, does anyone want to give it like a go? Oh my. Anyone like just like unmute if you want to try or type it in chat. Okay, so have you guys learned like the quadratic formula? Um, let's say thumbs up for yes. Melody says no. Oh, that's okay. So let's go over the quadratic formula first, because like you kind of need that as a base for Vieta's formula. And if we want to prove it, then you need to use like the quadratic formula. So basically, if we have like a quadratic ax squared plus bx plus c, like this one, which is equal to 0, we can use like we can do some like algebra on it, and then we get that like since it's a quadratic, then there must be like two roots, right? Then the two roots are x. Oh my god, should I write it down? Okay, so let's say the two roots are x1 and x2. I'm gonna write it separately so it's like clear. Equals to negative b plus and then like if it's not clear, then like the ABC are like taken from here, like these ABC, by the way. Yeah, b squared minus 4 AC. This is really annoying me. 2a. Sorry guys, I'm on laptop and yeah, it's so hard to like write. And that's a minus. Okay, is that like all goods? Should I go over the proof for this, or should we just like move on? Like thumbs up if like you want to go over the proof for this. Okay, let's go over the proof for it then. Okay. Actually, does anyone want to give it a go? Like Aiden, Isabel, do you guys want to try proving quadratic formula? Just say yes or no in the chat, and then yeah, not really. Okay. Yes or no, just like give me an answer. Okay, I'll do it then. So we have, oh my, I'm gonna use a text thing because this is really annoying. Actually, can I share a screen instead of share a whiteboard, and then I'll just do it somewhere else? Wait, actually, no, it's fine. I'll just do it here. All good. So firstly, we have ax squared plus bx plus c equals to 0, right? Plus, make this smaller. Sorry, guys. And then, since like, and then we can divide both sides by 0, right? So you get x squared plus b over a x plus c c over a is equal to 0, right? If any part of this doesn't make sense, then just like stop me, put your hand up, like or you can just like shout it out, or just like type in chat. Yeah. And then we can complete the square if you learned how to complete the square, but it's just pretty simple. So we know that we know that from last week, like last week, a plus b squared is equal to a squared plus 2ab plus b squared, right? So we'll try and put it into this. Wait, how do you like make it longer? This is not cool. All right, and then we try and put like this thing into like this form. Yeah. So we get x, let's just write it out fully then. X squared plus b over a x plus, since this part is supposed to be the 2ab part, so we divide this by 2 and square it. What's that? B over 2a squared. So b squared over 4a squared plus b squared over 4a squared. And then since this isn't equal to c over a, so we need to like, so we need to minus this, and then plus c over a again. Does this like make sense? If it doesn't, then just like tell me. Yes? No? Can I get like a thumbs up if it makes sense, please? Yay. 1. Okay. Oh my god, Zoom is so hard to use. It's not on one line and it's really annoying me. Okay. Equals to 0. So we know that this part can like make it square, so which is x plus b over 2a, this whole thing squared. And then we bring this part over to the right side. We get, let's just copy and paste this. And then we have to change the signs like that. All right. And then we can simplify, we can find the common denominator for the right side, so we can like simplify it. All right, minus c a, and then we find out it's, okay, b squared minus 4ac over 4a squared. Yeah. Now we square root both sides, but remember, like when you square root both sides, like you have to remember to do plus minus, right? So now we have x plus b over 2a is equal to this thing square rooted. So it's just the square root top plus minus square root of b squared minus for AC over 2A. And notice that this actually looks really similar to this, right? So we're like nearly there. All right. How do you move this up? Can someone help me move this text box up? Oh, yay. So since we only want x left on like the left side, so we get x is equal to this minus b over 2a. Since this has like a common denominator, so we can just go negative b plus minus that, and then this whole thing over 2a. Does that make sense? But then since it's like a plus minus, so it's two solutions, because like one solution is like negative b plus square root of that, and then the other solution is negative b minus that. Does that make sense? Like thumbs up if yes. Yay. Okay, I'm actually just gonna copy and paste a quadratic formula into here because my handwriting sucks. Right, it's there. Okay. Since these two are the roots, and then we want to prove Vieta's formula, right? And then Vieta's formula finds the sum of the roots and the product of the roots. So like, what can we do? We can just sum these up and like take the product of these as well, right? So when you take the sum of these two, you realize that the square root part cancels out, and then you get x. Okay, I'm gonna use a text box again. Oh my god. So you get x1 plus x2 is equal to negative 2b over 2a, right? And then this simplifies to negative b over a, which is exactly what it says in the formula. And then, okay, now we do the product. x1 times x2. We learned like difference of perfect squares before, right? And then we know that it's like the square of the first part minus square of the second part, right? And then and we realize that like these two times together we get like the difference of perfect square like formula, right? So we get the top bit is negative b. Just gonna copy this. Actually, no, it's just this bit. This is so annoying. The top bit is that times this. And then the denominator is 4a squared. And then using difference of perfect squares, we get b squared, that this is equal to b squared minus the square of this bit. So like basically the square root basically just like is squared back. So it's minus this. And then we can't forget the denominator. which is equal to 4a squared. And this is, and then the b squared and the b squared cancels out. So we get left with, this is equal to 4ac over 4a squared. And then the 4 cancels out and one of the a's cancel out. So we get left with c over a. So now we've proved Vieta's formula for quadratics. Thumbs up if that makes sense. Okay. So I'll move on then. Okay, so you might think like, if this Vieta's formula for quadratics then is there like Vieta's formula for cubics? Okay, this is supposed to be formulae, not formulas. But like, anyways, it's fine. So yeah, there is Vieta's formulae for cubics. And basically it states, okay, maybe I should just highlight this because I basically just wrote everything on the that's so bad. Maybe I should just like go like here. Yeah. It's basically like that. And then you might notice like a pattern, right? Well, let me just like explain this first. So like it's a sum of the 3 roots is negative b over a again. But this time it's not the product of the 3 rules that's c over a. It's the sum of the product of like every combination of like 2 roots, right? It's not just like x1, x2 plus x2, x3. It's x1, x2, x1, x3, and x1, x2, x3, which is equal to c over a. And this is positive. And the product of the 3 roots is negative d over a. So you might notice a few patterns. So it goes negative, then positive, then negative again, right? And then, wait, what was I gonna say again? I forgot. Yeah. Does that make sense? Yay. Wait, I was gonna say something. So like, well, you may ask like, if there's Vieta's formula for quadratics and cubics, and then you can like sort of notice a pattern, right? So you might like have already concluded like there's probably Vieta's formula for quartics and like higher powers, right? And there actually is. Can I get a thumbs up if you want to listen to like the general form of Vieta's formula? And then just don't say anything for like, yeah. Okay, let's do the general form then. So first of all, you have like a polynomial. Let me just make this really big. Sorry, I'm on laptop and this is like really bugging me. Oh my god, what happened? Okay, I'll just write here for now. Can everyone see where I'm like writing? Yes. Yes. Okay. Okay, so suppose you have like a1. So we learned about polynomials last week, right? And then so you have like a1x n plus a2x n minus 1. No. All the way to let me think, a n minus 1. Okay, so this is like a1 times x to the power of n, a2 times this, and then a1, a2 can be like anything, right? Times x to the power times x, and then plus a n equals to 0. Does someone want to like try and state part of Vieta's formula for this polynomial after like generalizing, after like noticing a pattern from previous ones? Isabel, do you want to try?
Okay, so like from the previous ones, we noticed that the sum of all the roots is like negative b over a, which in this case would be negative a2 over a1. Whoa.
Yeah, good job. You get 1 cookie. All right, so yeah, that's right. The sum of the roots. So the sum of the roots, let's just name them x1, x1, x2, all the way to xn. And then, as Isabel said, it's not x minus n, xn. The sum of the roots, as we noticed before, is like negative b over a, right? Which is, in this case, negative a2 over a1. So this is negative a2 over a1. Okay, so okay, so far. Does anyone want to try and like give me like a second rule? Or no? How about I tell you this? The second rule is x1 times x2 plus x1 times x3, and then all the way to xn minus 1 times xn is equal to something. Does that make sense? So basically, in the case of like 3, it's just, wait, let me think. Oh yeah, in the case of a quadratic, there's only 2 roots, right? So it's just x1, x2. And in the case of a cubic, there's 3 roots, right? So it's x1, x2, x1, x3, and x2, x3. Remember that like each pair is like, every pair is like chosen. So I can have like some random pair like x2, x8 in here. It's not just like x1, x2, x2, x3 all the way to xn minus 1 xn. Does that make sense? Yeah, okay. And then try and find what this is using like the patterns that we noticed before, wherever they are. Someone can just type it in chat and then yeah. Does anyone want to go? Agent, do you want to give it a try? No, not really. Okay, so we noticed that in our cube. Oh, wait. Yeah, oops. Sorry, I made a mistake here. There's there's n plus 1 terms, so this one should actually be a n plus 1. Yeah. Sorry. But that doesn't really affect what we said like before for this one. Okay, so we noticed that in our cubics, it was like the third term. I mean, we noticed that in our quadratics and cubics that it was like when there's like two terms, like the product of the two product of two roots, that it's like positive third term over first term, right? So in this case, it's a3 over a1. Does that make sense? Yeah. Okay. So since we know that this is like product of like two roots, then we can like predict product of like three roots, which we kind of already have in like cubics, right? So let's just have like x1, x2, x3, and then plus x1, x2, x4, and then this all the way to like this all the way to x n minus 2, x n minus 1, and x n. So we realize that it's like from like cubics is like negative the third term over the first term, right? So yeah, in this case it's negative the fourth term over the first term. Yeah. So in this case it's negative a4 over a1. Okay. Note that it's like always like changing between positives and negatives. So that means we know that product of four roots is like the sum of the products of four roots is like positive, right? And then we realize that the denominator is always a1, but then the numerator goes up in ones. It's a2, a3, a4, right? So this one must be a5 over a1. And then this continues all the way to the product of all the roots, which is x1, x2, x3, all the way to xn. And okay, so basically we know that it's like something a n plus 1 over a1, right? And then how do we determine if this is positive or negative? Does someone want to give it a go? You can look back at the quadratics and cubics. And then also realize that it's like negative, positive, negative, positive. How do we determine which one, if this is positive or negative? Yeah, so Isabel realized that this is like -1 to the power of n, which is basically saying like if n is even, then it's going to be 1, right? Because -1 to the power of any even number is 1. And then if it's odd, then it's going to be negative. So, because any number times by an odd number is, I mean, -1 times by an odd number is -1 still, right? So, yeah, it's basically just that. Like, that was not supposed to be a cookie. Times. Yeah. Does that make sense? This might be like a bit hard for like people who haven't really touched on polynomials and stuff. Yeah? Okay. Should we do some problems now? Why did I write that so far away from the actual thing? That's not cool. Okay. What's... yeah. Okay. Do the example problem, don't look at the solution. Can I like somehow cover up the solution? It's not working. Yeah, there. Do the example problem. This one. I'll give you guys until 8:10. Okay, does anyone have like solution? Just put it in the chat. Just go like, for example, sum equals to blah blah blah. Sum of products in pairs equals to blah, and the product of the roots. Yeah. If no one says a calculator. If no one says anything in 30 seconds, then I'm gonna just uncover this. Okay, I guess I'll erase all of this. Sorry, guys. Why is there so many? Thanks. So basically, we just apply Vieta's formula as it is. It's literally, what the hell? It's literally just up here, and then you just put it into that, and then it just works. Does that just make sense? Because I want to move on to typical applications, and then hopefully we can get through some practice problems. Okay. So typical applications. So the this is like mostly used to like find unknown coefficients, make new equations, and like stuff. Yeah, and then it's also like a foundation for like stuff you will learn later, especially something in Olympiad math called Vieta jumping, which was needed for NZMO 1Q8 this year. But let's not talk about that. Yeah. Okay, so let's go find unknown coefficients when roots are given. It's pretty self-explanatory because like if you're just given, okay, look up here at this like quadratic that we copied up here ages ago, right? So if you know, for example, if you know like a and like b, then you're gonna wait, let me think. Wait, let me think for a moment. Oh yeah. And then you're given like one of the roots, then you can basically just find the other root, right? And then plug it into C. Pretty self-explanatory, but like also if you're just given both of the roots and then you plug it into this formula and then you can just get this. Just saying, most of the times we take A as 1, so it's mainly just like x squared plus ax plus b, if that makes sense. Or just like plug x1, x2 into negative into this one, and then plus and then plug the product into C. Yeah, most of the times we just do that because it's like way simpler, and then it's basically the same thing. Cause like we can just divide by a, and then it gives us like the same polynomial. I mean, no, it gives us the same equation after we divide by a anyways, because the side's 0, right? Yeah, that, and then okay. So I guess like the hardest one is find the difference of the roots, right? So if you're given the sum, if you're given that like a quadratic, then you basically know like the sum of the roots and the product of the roots, right? But then you're not given the difference of the roots. And then also by difference, we take like the absolute value, so it must be like positive. Okay. Also, I forgot to mention before, Vieta's formula is mainly used in quadratics because, like, I mean, yeah, wait, I don't know. It's just like I've really only used it in quadratics. Wait, actually, no. This year's question 3 is used in cubics. Yeah, anyways, ignore what I said. So if you're given like the sum of the roots and the product of the roots, then you can find the difference of the roots, right? Because again, using this formula that we did like 2 weeks ago, you can, and then we also know that a minus b squared, that turned out very wrong. Squared is equal to this, but then the middle term is a minus. So we basically can just find the square. We can just find this, right? Because we have the sum, and then you take away 4ab, and then you get the square of the difference, and then you just square root it, and then you just, yeah, get the difference of the two, get like the difference of the two roots. Does that make sense? Yeah. Yes. If yes, then we're just gonna move on to like practice questions. Okay, let's do some practice problems then. Do practice problem 1. And then if someone solves it, then I will give them exactly 3 cookies. Alright, Cubone is pretty simple. It's basically just plugging it in. So this is basically just free cookies up for grabs. Anyone want to give it a try? Even if it's typing in chat, then it's still fine. If you're gonna type in chat, then just let me know like right now. Okay, no one. Okay. No one wants 3 free cookies. So basically we just apply Vieta's formula. Sum of the roots is negative b, and b is -7. So -7 is just 7, and then product of the roots is this term, and that's positive. And then, so that's just 12. Yeah, remember to like check like the signs of the terms, like if it's negative or positive, because if you make like a mistake, then you're kind of screwed. Okay, Q2. This time I'll give out 9 cookies. So, yeah. I'll give you until 8:21. It's pretty simple. Okay, Isabel, do you want to present?
Okay, yeah, I want cookies. So basically, if the roots are 2 and 5, the sum of the roots is 7, which is negative b over a. Since a is just 1, then b equals to negative 7, because negative 7 is 7. So p equals to 7, and then wait,
What?
negative 7. Sorry, I am glitching. And q equals to yeah, it's just c, and then c over a is just the product, and then 2 times 5 is 10. So q equals 10. Yay.
Okay, if Isabel didn't have that glitching moment, then that would be 7 out of 7. But since she did, so her final equation is x squared plus 7 plus 10, and that's actually wrong, so she gets 0 points. So yeah, but you still get 1 cookie because you tried. Yay. No, that was not a mouse slip. You said -7. Okay. Anyways, yeah. And that's that. Does that make sense? Like, yeah. If you're hungry, then just do problems and then I'll give you cookies. Okay, do question 3. It's pretty simple as well. Okay, does anyone want cookies? I mean, does anyone want to do the problem? It's like, okay, since this is the third problem, so it's 27 cookies. And it's pretty simple, so like, yeah. It's you guys can type in chat. Aiden, do you want to give it a try? Like, so like you can have some cookies. Just say yes. Oh, not really. Wow. Okay, Melody, do you want to give it a try? Some of the roots is. Yay! Yes, that's right. You get free cookies. 27 since it's 3 to the power of 3. 13, 14, 15, 16, 17, 18, 19, 20. Yeah, and this is a preview into our geometric sequences that we're going to talk about next time. Yeah, okay. Question 4. If someone can give me the answer within the next 4 minutes, then you guys can just go early. Yeah, that's right. It's wait. Let me actually think what roots that some. Wait, no, that's actually wrong. Um, so no, sorry, no cookies. Um, yes. And does x plus 3 times x plus 5 expand out to that? I think you're just missing like a sign. Yeah. Well, anyways, yes, it's x squared minus 8x plus 15, because the sum of the roots is like negative second term, right? And so it's so the second term is negative 8, and then the product of the roots is just the third term. So yeah, it's x. Yeah, yeah. 81. Isabel, where did 81 come from? Yeah, it also works, but you have to put like an equals 0 afterwards. Yeah, yeah, yeah. Are you just putting the 81 because it's 3 to the power 4 and it's a fourth question? Alright. Okay. I'll just give out 81 cookies for you guys to share. That's 81 right there. And that's basically it for today. If you guys have any questions, then you guys can just email me. Alright, and we'll talk about arithmetic and geometric sequences next time. Yay! Okay, bye, Melody. See you on Monday. Yay, thank you.